Hello. Okay, fine. Now it's visible, everyone. Okay. Okay, so recently in last lecture, I will explain you the what is hash function regarding some of the concept like MAC authentication code, right? So that concept that I have discussed. So again, quickly see some of the concepts. So I will discuss. That is, first of all, let's say start with the message authentication, and one by one, I will explain you all that concept. That is, what is hashing, what is message authentication, why we required, why we required see for authentication, which technique that we have to use. Everything that I will discuss today. Okay, so let's start with this concept. That is message authentication. So see, what is message authentication? So suppose let's say I can say there are two party that communicating with each other over a public channel, right? So this channel is public and this channel is captured by adversary, or you can say that the third party Oscar, who is basically called the cryptanalyst or hacker. So now what happened? So now authentication, what do you mean by authentication first of all? So there are two parties that communicate with each other over a public channel. So this channel is public and this channel is captured by adversary or the third party. Basically, you can say that it is called the cryptanalyst or a hacker, right? So now what happened? What do you mean by authentication? The authentication means suppose there are two parties, one is a Alice and another is a Bob. Then what happened? Suppose Alice is sending a message to a Bob, then now Bob has to ensure the message is coming from Alice, so that this is known as a authentication. Again, I repeat, what do you mean by authentication? If there are two parties, Alice want to send a message to us, Alice is sending a message to a Bob, so now Bob has to ensure the message is coming from a Alice, and that is known as a authentication, right? So how Bob can ensure that the message is coming from Alice, it's not coming from a Oscar or some other party. Means let's say the now it is not coming from the third party, or let's say attacker, or you can say that cryptanalyst, right? So that it is known as a method message authentication, right? So now question is your mind, how the Bob can ensure the message that is coming from the allies. So here in this case what happened, so the allies you can say that so how allies can say that the message I am sending, so the one way is to what we have to do, so they have used a symmetric key setup, right? And they agreed with a common key. So again, I repeat everyone. So the message authentication means if Allah is sending a message to a Bob, the Bob has to ensure that the message is coming from Allah. And this is known as the authentication. So now the question arises, that is how the Bob can ensure that the message is coming from Allah, right? It's not coming from other, okay, third party or cryptanalyst or something. So for that, what you have to do? So one of the way is what the symmetric key setup is used, means both the party Alice and Bob that agreed with a common key. So I think see all that example that I have covered, but see just again in brief, see in last lecture quickly I have go through all that concept. So again in deep, right, I will go each and every concept today, so you can understand how agree. So the one way that is they have suppose they have a symmetric key setup and they agreed with a common key, right? So now if the both the party they have a common key k, so now in that case what the allies will do? So first of all the allies can encrypt the message. What the allies will do? So see, first of all I draw the figure here so you can understand. Let's say here I can say the allies, okay, original message and first I will write the figure and then after I will explain you. So now what happened everyone? So suppose see the same scenario, allies want to send a message to a Bob, right? This is a Bob. Now how the Bob can ensure that the message is coming from allies, right? So for that, yeah, so this is known as a this is known as a message authentication, right? Now for that these steps are performed. So first of all what happened? So let's say some original message, let's say some message is there. So what the allies will do? The allies can do, and see in this scenario, suppose they have a symmetric key setup and they agreed with a common key k. Both the party that agreed with common key what k. Now here in this scenario what happened? The allies can encrypt this message using either you can say that block cipher or a string cipher, right? So first of all the allies encrypt the message. Let's say that encrypted message is known as a C. Now what the allies will do? Now allies allies encrypt the message by using k. So by using this block and string cipher, now the allies after that what happened? So after that this cipher text, that is C, sorry sorry everyone. So now what happened? So along with this, along with the message, so now the Bob receiving the message along with the encrypted message. So first of all, allies encrypt the message. Now then after the original message along with this encrypted message, that is send it to the Bob. So now what the Bob will get? Now Bob receiving the message. Bob receiving the message. Let's say this encrypted, it is known as a Y. Here I have written. So now along with this message, Bob receiving the message and then encrypted message, right? Now what the Bob will do? So what the Bob can do? So now how the Bob will authenticate the message is coming from allies. So what the Bob will do? First of all, Bob here, Bob decrypt. See why? So Bob decrypt it, right, with this key. So when the Bob decrypt it with this key, so what the Bob will get? The Bob will get the M. So now these the what? These you can say that this is the original message, and here you can say that after the decrypting, so whatever the M you are getting, so this M message is compared with this message. Okay, if the comparison is done, if both the messages are same, that means you can say that here the Bob will ensure that the message is coming from allies, and in this way you can say that the authentication is done. Up to this clear everyone? So again I repeat, first of all the message, the allies, what the allies will do? Allies encrypt the message. Now the message along with the encrypted message is sent it to the Bob. Now in Bob's side, how the Bob can ensure that the message is coming from Alive. So what the Bob will do, the Bob, because both the party they agree with the common key. So now what the Bob will do, Bob decrypt it with this with the help of this key. Bob decrypt it. So when the Bob decrypt it, Bob side get the M. So now this message is compared with this message, right? If the both the messages are same, that means you can say that the Bob will ensure that the message is coming from allies, and in this way the authentication is done. Is it clear to you all up to this? Hello? Okay. Okay, now see here in this scenario, what happened? So when the comparison is done, so now here, see this figure. So Bob will ensure that the message coming from allies, right? So here in this scenario, you can say that authentication is done, right? So now see here in this scenario, see this is the concept of message authentication. Now I think all of you are clear in this concept, right? Message authentication. But now here in this concept, what happens? Some issues like the message, see here whatever the message is there, see in this scenario what happened, so the when here in this scenario the message with what this encrypted message that is sent it to a Bob, right? So now here you observe that the message is what it becoming a public, whatever the message is there it is becoming a public. So here you are sending the message, so here we are not bothering about the confidentiality of the message, right? Here we are not bothering about the confidentiality of the message. Here right now I'm interested only on a what authentication, but here in this scenario some even issues is there, that is the message is becoming a public, and when message is becoming a public, so here you are sending the message, we are not bothering about the confidentiality of the message, right? Now suppose let's say the message is a big message, right? The message is a big message. So this whatever the encryption technique that we are using, either you can say that, let's say in this scenario I am seeing that the block cipher or string cipher, let's say I am using. So now suppose my message is very long, then the encryption becomes very costly. So now just for authentication, just only for the authentication, we don't need to encrypt the whole message, right? Only for authentication, we don't need to encrypt the whole message, right? So for that, what we have to do, right? So see, if you are using this technique and let's say my message is very long, then what happened? The encryption is becomes very costly. But see, if you are only interested for if you only check for whether the authentication is done or not, right? So when Ella is sending the message to a Bob, and Bob wants and Bob here in this scenario, the Bob can ensure that the message is only coming from allies. So in this scenario, if my message is very large, then this encryption that become very costly. So just for authentication, we don't need to encrypt the whole message. So now what you have to do? So that I will explain you next. Now see the figure. Okay. Now, suppose, listen everyone, my message is very long. Say, let's say the M I can say it's a 1024 bit. Okay. So now, suppose if my message is very long and if I'm using this encryption, see if I'm only just for authentication, what happened? If you are using this, if your the whole message is encrypted, then it becomes very costly. So for that, what is one way? That is, suppose my message is 1024 bit, right? So now for that, what we have to do, so we will choose some of the bits. Let's say 8 bit, I can say, see here, instead of 8 bit, I can say 16 bits, right? Like in this way. So so basically what we are doing, so basically we applied the function on this, right? Means we take some of the bits from this message, not the whole bit, right? We take some of the bit from the message, right? Not the whole bit, and this, what, let's say you can say that M star, that is of lesser size. So right, so what I'm doing here, so from that, let's say, see here, let's say I'm taking this bit, I'm taking this bit, let's say this one bit, and I'm doing, so I'm applying some function. Let's say I'm some of the bit that I'm taking, and finally I'm getting M star, and that is of what, lesser size, right? And so that there could be the one way of that could be a one way, right? So we can just do the bitwise XORing of some of the block, and then we can give it to a fixed block like in this way. So in this way we are getting the laser size. So again, I am repeating everyone. So if I'm only interested for let's say see authentication, if my message is very long, let's say 1024 bits, right? So if the entire message is encrypted, it becomes very costly. So for that, what we have to do, so let's say here I can say that let's say some of the bits that I am choosing, let's say 8, 16 or something, and then after, what we have to do, so here you can say that we take the sum of the bits from this message, not the whole bit, and then so finally, what, let's say I'm getting the M star, means let's say and see whatever the bit that I'm taking, let's say do the bitwise XORing, right? So finally, what, finally the lesser size of message that I am getting, and then after you have to perform the encryption. So these are one way that you can apply. Okay, now here you can say that suppose, let's say if my whatever the lesser size that I am getting, okay, so suppose, let's say I can say that if it is a 64 bit, right? So which technique I can use for symmetric key encryption? I think all of you are studying symmetric key concept. So if the message of size 64 bit, then which symmetric key encryption is used? Please write down in the chat window, everyone. Priyank, that type of mechanism is there. Both the party know this thing I am doing. Yes, Urjit, you are correct. So here you can say that if my message, whatever the message that I am getting, right, if it message is of size 64, so in that case, this is for symmetric key encryption, the DES is used. Let's say I can say that if the size is 128 bit, then which technique is used for encryption? Can anyone tell me which technique is used? Okay, so I think AES is done in your class, everyone. Urjit, AES is done. The concept of AES is done in your class, Urjit. Can you hear me? Okay, so fine, everyone. So if it is a 64 bit, then we will go for DES as a asymmetric key encryption. And if it's a 128 bit, so one can go for the AES, or one can go for the cipher for the encryption purpose, right? So now from this, see here in this scenario, I can say that from M, what I'm getting. So now, so here in this scenario, how the encryption is done, everyone. So if the message is very large, so see, I'm writing in this way. So from whatever the M is there, what I am getting from M, I am getting some of the bits are taken, and from that I am getting M star that is of lesser size, right? Now again, what happened? So now on that, see both the party know the symmetric key that is K. Then let's say these are allies, right? So now if the message is very large, so now choose the sum of the bit, do the XORing, and from that it becomes of lesser, it becomes a lesser size. Now then after, see if the size of 64 bit, then let's say you can say that DS is used. Now on that, what happened? Whatever the M star that you are getting, first the encryption is done, right? Now the message, now here you can see that message along with this encrypted message, now it is sending to the Bob, right? Now, so what the Bob will get? So let's say this denoted as a Y. So the Bob get these two things, right? Now on Bob side, what happened? So here you can say that on Bob side, the Bob perform what? The decryption with the same key. So here Bob get the M star, and also see here when I'm sending M. So again, see here I told you that some function is applied, and based on that you are getting M star. So again here the same thing is done. The function is applied, and then you get M star, right? And see here the same function is whatever the function is applied over this side, and then you get M star. The same function is applied over here, and then you get the lesser size of message, right? And here in this case, what happened? Both the message, so here the comparison between both the messages are done, and if it is same, then you can say that the authentication is done. So is it clear to you all this scenario? Please reply. Is it clear? When the message is very large, then what happened? Is it clear to you all? Please reply so I can understand. Can you hear me, everyone? Hello? Can you hear me? So all of you yes means okay. So now see, this is the scenario that I have discussed. See, listen everyone. So in this scenario, what we have done, so if my message is very large, I am taking some of the bit, right, applying some function, which do the XORing, right, whatever the bits are there, do applying this function. And finally, I am getting the message of lesser size. If the message of lesser size of 64 bit, I am using the DS for encryption. The message along with the encryption, now it is sent it to the Bob. Now what the Bob will do, in Bob side, both the party know in this scenario, the symmetric key setup is performed. Both the party agreed with this common key, right? Now here Bob side, what happened? The decryption is done, and here Bob get M star. But here the original message is there. So again in Bob side, again it applied this type of this function, and then again get the M star. And both the both the messages are compared, and if it is compared, then you can say that the authentication is achieved. So in this way, if the larger size is there, if the message is very large, so in this way you can say that the authentication, for authentication you can check. So this is the one way, right? This is the one, you can say that this is the one way. Now the another way, right? The another way we can compress, see original message is very large, so this is the one way to compress the message, and by using you can check the how the authentication is achieved. Now what is the another way? The other way we can compress this message, that is known as hash function, and that is known as a what? Hash function. So see, I will not provide you this material. See, some of the concept of hash that already that I have discussed in your class, but in detail today I will explain you. So why we are using this concept, right? So this is the one way by using you can compress, and another way the message you can compress the message, that is known as a what? Hash function. Right now let's discuss with the hash function. So up to this clear, everyone? Okay, fine. Now, first I will draw the figure and then after I will explain you. Now, see here in this case, what happened in this hash function, we are taking the whole message. We are taking the whole message as an input, right? And it could be of any size. It could be of any size arbitrary, right? So we have a big input. We have a big input, any size m, which is the message, right? And here you can say that we have a function, we have a function has function which is taking this whole message. See the message of variable length, the message of variable length, and what this hash function will do. So hash function is taking the whole message as input and it is giving a fixed size digest, and this is known as a hash code. So this is known as a message digest, or you can say hash code. Now the question is your mind, that is which hash function is used. So in next to next lecture I will explain you MD5, SHA512. These are the technique. These are the functions by using the message digest means hash code is generated, right? So in next to next lecture, that has function, different hash functions are there that I will discuss in next to next class, right? So right now we have to remember that some hash function like SHA512, MD5, this type of function is there. So what it will, what the function will do, it take the variable length message as a input, and then finally after applying this hash function, what you get the fixed size digest, and that is known as a hash code, right? So simply you can say that here I am writing. So let's say the variable length is like this, right? And finally after applying this hash function, what I am getting, so I am getting, let's say, this some fixed size length, right? Now okay, just wait, again I'm opening the another whiteboard. So suppose let's say now the scenario is there are two party. So I think all of you clear why we need the hash function. Basically, if the message is very large, and one of the way that I have discussed, so that is some of the bits that we are taking and then XORing it, and then after applying the key, and based on that we are compressing the message, right? And means in this way we are compressing the message and check for authentication, right? That is the one way that we have I have discussed. The another way that I have discussed, how can you compress the message? By using this hash function, right? You can compress the message. So up till now all of you done? Ujit, what is your question? I'm not getting.
Why we are using such hash functions when we can do message authentication without that?
Uh, what message authentication? Pardon, Urjit?
Ma'am, message authentication means right, like we are doing here, that we are seeing that our message is not modified and in both the sides, right? So without hash
See,
function, we
yes,
are doing that.
yes, without listen, without hash function you are doing that, right? Only see first figure मैंने आपको जो बताई उसमें मैंने बोला आपको hash function का यूज नहीं किया, right उर्जित?
Yes, ma'am.
राइट उसका यूज नहीं किया, लेकिन हम हैश फंक्शन का कब यूज, व्हेन इट इज यूजफुल. सी नॉर्मली नॉर्मली मैसेज, कोई भी मैसेज सेंड होता है तो मैसेज एकदम स्मॉल नहीं, जैसे हम आप SHA 512 नॉर्मली normally in hashing SHA 512, not MD5. I will explain you, but SHA 512, that type of technique is used. Also, see in symmetric, also you learn that DES, AES, that are working with 64 bit, 120. AES is working with 128 bit, right? So normally the message is very large. What I'm doing trying to say. So if you are not using the hashing technique, you are not compressing it, then what happens? It becomes very costly. Without applying the hash function, if the message is sending, so basically why we are using the hash function, what the hash function will do, it will compress the message. And finally, see, let's say there's some variable length message, the message is very large, and if I'm applying it to some hash function, let's say SSA 512 or any hash function I am applying, right? So finally, as an output, what you get, the fixed size message that you are getting. And after that, whatever the message you are getting, fixed size, then that with the help of key, you that fixed size message you have to encrypt. So now, see, without hashing, if you are encrypted the message, then it becomes very costly, Urjit. That's why we are using that. Yes, the hash function is used for compression, compressing the message, for lowering the cost. Yes, Urjit, you are correct. Now clear, Urjit, right? And see other technique that I have explained you, some of the bits that we are taking and that one, right? But normally the hashing is used. Right, see, these are the different way that I am explaining you, right? See, in the first scenario, very first figure, see, in that I have assumed that my message is not long. So directly in that scenario, see, my what is my purpose? My purpose is the message authentication. And what do you mean by message authentication? So if Ally send the message to a Bob, then how the Bob can ensure that the message is coming from Ally? Right, so in this scenario I have assumed that both the party, they agree with the common key, so allies encrypt the message, right? And the message along with that encrypted message is send it to the Bob, and what the Bob will do, the Bob decrypt with the same key, right? And then both the messages are compared, right? That figure that I have explained and then in the very next figure, the second figure, what I am trying to say, in that scenario, the scenario is my message is large, right? So if my message is large, right, and if I'm not compressing my message, then what happened? So here in that scenario, you can say that it becomes a very costly. Yeah, so that's why one of the technique that I have explained, that is some of the bits that you have to take XORing or it, and in that way you have to compact. That is the one of the technique that I have used. And the another technique that I have explained, that is hashing is a way for compressing the message, right? So before performing the encryption, first you have to, if message is very large, first you have to use the hash function, so we can compress the message, and then after you have to apply the hash encryption technique, right? So normally this hashing technique is used. So is it clear to you all what I'm trying to say? Is it fine, everyone? Okay. So now see, suppose now the next figure I will explain you, where you have to assume your message is very large. Okay. So now if my message is very large, what I'm doing, I'm applying the hashing technique. So first of all, when I'm applying the hashing technique, what I'm getting, the fixed size. So the message of variable length, then what I'm getting, I'm getting the fixed size hash code that I'm getting, right? So now here, now what I'm doing, so see the figure. So now my question is, my message is very large, and the question is, I want to check how the authentication is done. So now what I'm doing here, see the figure. The message is large. Now in this case, you have to take this two party, Alice and Bob. And what is my question? How authentication is done? How the authentication is done, right? So So now for that, what I am doing here, let's say these are allies. And see here for encryption, see that thing you have to remember both the party have a common, they agree with the common secret key K. Okay, so now see by using the this different scenario, I want to explain you message authentication, digital signature. So these all concepts are linked with the first one, first, second, third. These all concepts are linked, right? So let's say this is my original message. Okay, so now my message is very large, so you have to assume that I'm applying the hashing function. So when I'm applying the hashing function, I'm getting hm means that is a fixed size hash code that I am getting. Right now, what does, so first of all, allies perform the hash function, and based on that, allies get this hash code. Now what the allies will do, so what the allies will do, so allies encrypt the message by using this key, whatever the hash code. Now, so first of all, original message, first of all, hashing is applied. So what you get, the hash code is you are getting. Now what the allies will do, whatever the hash code the allies is getting, so encrypt it with key. Okay, encrypt it with key. So let's say it is known as a Y, and then after, what the allies will do, so the original message along with this encrypted message, that is known as a Y. Right now it is send it to what, now it is send it to the Bob. See this figure. So now when it is send it to the Bob, so all of you know that the Bob have a key, right? The key K is common between the both the party. So now what the Bob will do, now see this figure. So now what the Bob have? The Bob have this M and Y. Okay. So now what the Bob will do? So the Bob perform the decryption algorithm, right? So Bob perform the decryption. So now when Bob perform decryption, so instead of Y, what can I write? EKHM. Instead of Y, I can write in this way, right? So when the decryption is performed, so what you get? This hash code that you are getting. Right now, again, on this Bob side, what happened? Whatever the original message is there, on that again the some hash function is applied. When the hash function is applied, what you get? HM. Right, so now then after, what happened, both the hash whatever the, here you are getting this H and here H, so both the hash code are compared, and when the hash code are compared, then both are compared, and when the comparison is done, if it is same, if same, then you can say that the authentication is done. Now is it fine, everyone? So if message is very large, so what the allies will do? Allies perform some hash function. So now after applying the hash function, so what you get? Hash code. Right now the question is how the authentication is done. So for that, what the allies will do? Both the party have a common shared secret key K. So now what the allies will do? First encrypt the message, whatever the hash code the allies is getting, right? Encrypt it. Let's say it is known as a Y, and the original message along with this encrypted, it is send it to the Bob. Right, so now Bob get the original message along with this encrypted message. Right now what the Bob will do, Bob have this key, so Bob decrypt it. So when the Bob decrypt it, what the Bob will get? Bob get the hash code. Right, and again on the original message, the hashing function is applied. Right, the same hash function is applied, and then what the Bob get? The hash code. Now both the hash code are compared, and when both the hash code are compared, then you can say that the authentication is done. Is it clear to you all? See, today this approach is fine. Do you like this approach, whiteboard approach, everyone? Okay. So other students, is it fine? What about other student? Is it clear to you all? Okay, fine. Thanks for replying. Right, so in this way you can say that when my message is very large, and see how the authentication is achieved. Right, now again in the same scenario, right, again in the same figure, now which type of problem is occur? Right, so now that I will explain you next. Sorry. Sorry, everyone, just wait. Sorry. So now let's discuss the problem with this authentication scheme. In this authentication scheme, right now all of you clear with this, right? So what is the problem with this authentication scheme? So this is a sort of this is secured against the third party, right? So now see this technique in this by using this scenario, what happened? It is this sort see this is sort of this, it is secured against the third party. If there is a third party, let's say Oscar, I can say that, or Eve, I can say that there is a third party, right? So the third party cannot do anything here in terms of authentication. Why? Because the Alice and Bob both have a common key. The Alice is having a message, so simply Alice is, and all of you know that the Alice is encrypting the message, right? So here you can say that the message is the message of 64-bit. Then you can say that the DS algorithm is used, DS encryption technique is used, and Alice is sending the message along with the Y to a Bob. So by seeing this, the Oscar cannot do anything because the Oscar cannot encrypt this again and encrypt the message, because Oscar is not having a secret key, right? So just remember that in this and in this particular how in this authentication, what happened, the third party cannot do anything. Why? Because the key is secret between both the party, right? So when the message is sending, see here what happened, when the message is sending, so at that time you can say that the Bob does not do anything, because the Bob cannot have this key, right? Now what happened? So now what happened, the Bob will receive the M and Y, right? All of you know that the Bob will decrypt it by using the decryption algorithm and get the message. But see here in this scenario, what happened? So suppose, let's say the Bob can change the message, right? Let's say the Bob can change the message M to M star, right? And Bob can encrypt this with the Bob can encrypt this with this M star with the same key, and Bob can claim that this message is coming from Alice. So here you can say that the Bob can force by changing the message, because there is no way the Alice can prove that the C did not send this message, right? So to prevent this attack, the new concept is introduced, that is digital signature. See, again I repeat everyone so you can understand. Just wait, again I repeat. And see here in this scenario, listen everyone. So here in this scenario, just you have to remember that we are not bothering about the confidentiality. Right now, I'm only checking for authentication, right? We are not bothering about the confidentiality. Now see in this scenario, again I repeat everyone. So here in this scenario, the third party, if there is a third party, Oscar cannot do anything in terms of authentication. Why the third party cannot do? Because here you can say that the key is shared between both the party, Alice and Bob, right? The third person, Eve does not have any key, and that's why you can say that the third party cannot do anything. But here in this scenario, what happened? The Bob can be maliciously, like Bob can cheat the Alice in terms of this type of authentication scheme. The Bob can cheat the Alice. How the Bob can cheat the Alice? Because both the party have a common key, right? So how the Bob can cheat the Alice, right, in this authentication scheme? So now remember here in this case what happened? So first of all, the Bob when the Bob will receive the this M and Y, what the Bob will do? The Bob will decrypt it by using the decryption algorithm. All of you know that, and get the message. And in this way, the Bob get the message, right? The Bob get the message. Now what happened? So once Bob get the message, so at that time what happened? The again what the Bob did, the Bob decrypt the message using the decryption algorithm. So once Bob decrypt the message, so what the Bob will do? The Bob again Hello everyone, can you hear me? In whiteboard, the last figure, all of you, the figure is in your mind, yes or no? See, remember that figure, everyone. So, in that scenario, what I want to say that, see, both the party have a common shared secret key. So the third party cannot do anything. But here in this type of authentication technique, what happened? Uh, now it is clear. Hello, my voice is clear to you all. Please reply. Hello. Now Priyank, it's fine. Hello. Now is it fine? Okay, just wait. I'm going outside. Now is it fine? Okay, so listen, just you have to remember that last figure. All of you know that. So all of you know that in that figure, what happened? The third party, right, cannot. You can say that encrypt this again because the Oscar is not having the secret key, right? All of you know that. But the thing is, Bob can maliciously, like Bob can cheat the allies in this authentication scheme. The Bob can cheat the allies, right? Now, how the Bob can cheat the allies, everyone? So the Bob will receive, all of you know that figure, that is Bob will receive this M and Y. Bob will decrypt it by using the decryption algorithm and get the message. Now once the Bob get message, what the Bob will do? So the Bob can change the message to, let's say, M star. Right now the Bob have that key. So again, whatever the when after changing the message, again what the Bob will do? Now Bob again encrypt the message, right? And the Bob claim that this message is coming from an ally, right? So Bob, in this way, the Bob can cheat the allies. Okay, after changing it, encrypt it, and then the Bob says that okay, this message is coming from an allies, but it is not coming from allies. It is coming from Bob, right? And so here you can say that the Bob can force here by changing the message because there is no way. See, there is no way the allies can prove that, right? C did not end this message, right? Here the what the Bob have done, the Bob, because the Bob have a key, so the Bob have a message, Bob changed the message, encrypt it, and claim that this message is coming from allies, but actually the message is coming from Bob. So in this way the Bob can cheat the allies, and allies can't prove that the C did not send this message, right? And that's why there is no way the allies can prove. And that's why to prevent this type of attack, the new concept is introduced, that is digital signature. So when you are using that digital signature concept, so from that, see if this type of the if the Bob can cheat the allies, then allies can prove that okay, these are message from me. These are not message from right. So this type of attack is not possible if you are using the digital signature concept. Is it fine, everyone? Is it clear to you all? Hello, right? Okay, fine, everyone. So, see, the next topic I will explain in next class because see, I can't share my screen. Okay. Okay, fine, everyone. Thank you, everyone. Okay, and listen, everyone. There is one announcement. Just listen. Uh, the classroom is created for NIS subject. Okay, so in that classroom, all the assignments are also uploaded, right? Whatever the, I think up to how many labs are finished, everyone? Write down in the chat window. How many labs are finished? 7 or 8? Hello? Please write down in the chat window 7 or 8. How many labs are finished? 8. Okay. So now see again you have to upload all these 8 labs in that assignment in classroom. All the labs that you have to upload, everyone. Okay. So up to lab 8 you have to upload in classroom. Chandris, what is your question? Please unmute yourself. File name means what is the format that you are asking, Chandresh? Okay, so that we will provide you. Okay, okay. And thank you, everyone. See, in announcement section, today I will provide you, okay, in which format you have to upload. So all the lab 8, all this lab 1 to lab 8 that you have to upload in a classroom, everything. Okay, fine, everyone. Thank you.